Hello! This is the last video for the Calc 3 class. And this video is going to be talking about Stokes' theorem and the divergence theorem. So they're two somewhat complex theorems that I'll give you a basic definition to them here. And in class we'll go over them a little bit more and see some of their uses. Okay, so let's dive right in. So first of all, Stokes' theorem. So let S be an oriented, piecewise smooth surface that is bounded by a simple, closed, piecewise smooth boundary curve C with positive orientation. Let F be a vector field whose components have continuous partial derivatives on an open region in R3 that contain S. Then the integral of f is the same as the double integral of the curl of f over the region. So it converts a line integral into a double integral, but it's just dealing it with over the curve or the curl, and it's on the region that's bounded on the inside as opposed to the boundary. So Stokes' theorem is just another one of those setups that's dealing with the conversion between the boundary and the region inside. As you go further and further into mathematics, you'll find that this is a fairly common setup. So that's Stokes' theorem. The next one is the divergence theorem. So let E be a simple, solid region. So that implies it's going to be a three-dimensional region. And let S be the boundary surface of E, given the positive outward orientation. And then let F be a vector field whose component functions have continuous partial derivatives on an open region that contains E. Then the double integral of F, so the surface integral, is the same thing as the triple integral of the divergence of F. So before we talk about curl and divergence, here's two separate theorems that I'm using the curl and the divergence. Alright, so that's the last of these videos and the last information for Calc 3 that I'll be putting up here. Hopefully you learned something, and I'll see you in class.